Hello, welcome to biology lesson. This kind of covers lessons 26 and 27 about the human impact on the environment. All right, so you have population growth with 6 to 8 billion people in the world, 95 million babies a year, and this number is probably a little off now, but that's an average of 3 babies per second. I believe in one of your discussion questions, it touches on this. Has the rate of population growth always been the same? Well, let's see if we can answer that question. So human population is growing exponentially. So the larger the population, the faster it grows. That makes sense, right? There's an increase in average life expectancy, and that's part of the reason responsible for the rapid increase in population. And why do you think that is? What are some things that are going on today that weren't 100 years ago? I actually have this book I like. It's called The Great Influenza. It is a history, although I know that sounds boring, but it's really interesting. A history of the creation of the vaccine against the Spanish flu and the medical field. So you got to see how that developed over the same time span. Talks about the immune system in detail, but everything is very much simplified for the layperson, someone who's not familiar with immune system terms and all of that stuff. It's really, really good. And you can kind of see how the answers to this question fit in when you read this book. So, one of the reasons we have better health care, better hospitals, better medicines, better vaccines. We have more food and the food is better, more nourishing. We have cleaner water. So back in the day, there was a well and people were getting sick and dying with diarrhea or dysentery. And they found that one of the wells was contaminated. And when people stopped using that well, they stopped getting dysentery and dying. So that was one way they found out, oh, we need to keep the water cleaner. And then better sanitation. So we're not dumping chamber pots out onto the street. Chamber pots are those little pots that people would pee in at night. It was like an inside porta potty or outhouse, only it was an in-house. And so they would take that and they would dump it in the mornings. Not very sanitary. And the biggest increase in the population is in economically developing nations. So rather than economically developed nations. So why do you think this might be? Why would a nation that is still developing have a bigger increase in population than one who is already developed? Okay, so in the year 2000, the population was 6.1 billion. All right, so you can see 1750 as it went on, and then from 2000 it's exponential. We're not to 2050 yet, but you can see that 2050 is going to be up here in like the almost 10 billion. And then by 2150, probably 11 billion. So this shows you how the more developed countries have fewer and the less developed countries have quite a bit more. So computer models can be used to make predictions about population growth by using assumptions about birth rate. Analysts will assume birth rates will fall within the next 50 years. Why? Well, there's decreased fertility, lack of resources, disease, and more. So let's think back to the question I asked a minute ago about why would developing countries, economically developing countries, have more growth. Okay. Now, as you go, right, if they're economically developing, that means they have resources available to them. So more resources, more food, that type of thing will help or allow them to have children, because now they can support them economically, nutritionally. Decreased fertility, well, that's for birth rates falling, but in economically advantageous or economically developing nation, as they have more money, more resources, then they have more children. If they don't have money, they don't want to have children. If they don't have food to feed the children, they don't want to have them. And then disease, as it's developing, there's no more disease, or well, they've got vaccines, different things to and facilities, hospitals, things like that to help when you're sick. So all of that goes away. And then again, they have better sanitation. So, you know, more money means that there's you can make a better life. So how important do you think predictions about climate change and unsustainable development are in an analyst's calculations? Well, probably pretty important, right? They have to know, are we running out of land? Have we just destroyed things? Can we grow plants? A lot of different things go into analyzing climate change, how that'll work. You know, are we deforesting? Deforesting is not really a good word, but are we killing trees? You know, a rapid increased deforestation, you know, what's going on with all of that? They take all of that into account. So using resources and producing pollution. More people get you more raw material. You're using more raw materials, such as minerals. More people means you're using more land, so buildings, farms, quarries where you're mining, and dumps. More people also means using more energy, which means more fossil fuels for the gas to transport. More people, though, produce more waste and more pollution. So we use pesticides and herbicides. The DDT, one of the discussion questions talks about DDT. It was outlawed in the 70s, I think. They found it was great at killing things, but they found that it caused a lot of birth defects during that time. And it is actually still found in the soil in certain areas in the fish population. But I don't remember what else. But it's still there. It's not breaking down. It's not going away. So you have to be careful of that. We also produce more sewage, more fertilizer, more toxic waste. Animals, if we have more animals, their manure goes into the ocean, contaminates the ocean. Obviously, toxic waste, you hear all the stories about dumping illegally. I think in Nevada, I believe we have a place now where we deposit toxic waste. If any of you guys want to see a funny movie, Fletch, with Chevy Chase, the one where he inherits property from his aunt called Belle Isle. It's kind of funny. It talks about the toxic waste. You also have more carbon dioxide, that's the CO2 given off, more sulfur dioxide, that's the SO2, more carbon monoxide, the CO, and smoke given off. All of those go into the air. They help with, like in Arizona, we have the greenhouse effect. So we've got clouds, we've got all this stuff that traps these different things in an inversion layer. The ground gets hot. The heat doesn't dissipate. These chemicals keep getting recycled. And then gets hotter and hotter and the air gets worse and all that good stuff, huh? That's why we like the wind to come in, because it blows that crap out, blows it all the way over to Roosevelt Lake. About 4 o'clock at Roosevelt Lake, there is the highest that their pollution is. And it's because it's all been blown from the valley over there on its way out past Roosevelt Lake. So one of the biggest problems of rising population is an increase in pollution. So what is a pollutant? It's a substance that contaminates air, water, land, can be caused by natural events such as volcanic eruptions. Majority is caused by human actions though. Now when we had that big, huge eruption 5 years ago, something like that, it actually, the volcanic ash and the damage that it caused by blocking the sun and throwing all that stuff into the air circled the globe. It actually messes up the climate process as well. It interferes with the rain, it interferes with the wind, interferes with the sun. There's a whole lot of blowback, if you will, from volcanic eruptions. So pollutants are either non-degradable, like DDT, which we just talked about, and they decompose so slowly that they're basically non-degradable. This also allows them to accumulate to toxic levels as they're passed along the food chains. When you're talking about the energy cycles, trophic levels, and it's a pyramid, so it goes from big at the bottom to small at the top, and that's talking about the amount of energy obtained from eating the different animals. So the animal that eats the plant gets the most energy. Then the animal that eats that animal gets 10% less, and on up through the chain to like the eagles, which are primary predators. But as it moves up the chain, these non-degradable toxins like this DDT become stronger and stronger and stronger. So they usually accumulate in the liver, and so they become even more toxic, and so it can kill these birds, these animals, as it becomes more toxic within the food chain. They also can be biodegradable, like sewage. These are usually only damaging when they're added more quickly than they can decompose. We do have that issue, as I mentioned, like the fertilizer, that type of thing going into the ocean. Now, the land and soil can be polluted by two main substances. We've touched on it in the last slide. Solid waste, plastic, metal, paper, man-made substances, although now they have invented plastic, the rings that cover the cans of soda. When you buy a 6-pack or 10-pack or whatever, they're actually making those biodegradable. I don't think they've hit the market yet, but they're making them right now. So that if it hits the ocean or the ground or whatever, they'll biodegrade quickly. But here you also see car parts in the picture, so those don't break down very fast. Chemicals, so herbicides, pesticides, crude oil, waste from industrial processes. That's why they don't want you to change your oil and then go and just dump it in the ground. It doesn't break down. Land pollution often leads to water pollution as chemicals are washed into rivers and lakes. And I mentioned that before as well when I talked about the cows with the manure, the nitrogen, all of that going into the ocean or into water. They're having what are called bleached reefs, coral reefs, because the nitrogen, all that stuff that goes into the water sits on the surface, and coral reefs actually photosynthesize, so they need that sunlight. If that sunlight is blocked, they'll die. So that's one of the reasons we're getting bleached coral reefs. Well, that's kind of a trickle-down effect because they house a lot of different sea life and they feed a lot of different sea life. So if those go away, then we've got other problems. So it's not just as simple as going into the water. How much do we waste? Oh my gosh, we waste a ton. Every year, billions of tons of paper, plastic, synthetic materials, metal, and wood are thrown away. Now, the wood you can burn on no-burn days in Arizona, in a fire pit or controlled environment. You know, recycling is much better. You've got the stores, Target, Walmart, Lowe's has a couple of recycle bins too, so you can recycle paper bags, cardboard boxes, plastic bags. The grocery stores also have a spot so you can throw plastic bags in their bin and they'll recycle them. Metal, I'm not sure. I guess you could take that to the dump. Some things, you know, take to, there are stations, like Queen Creek has a recycle station. You can take televisions, you can take trees, brushes, all that. They will take that and they will sort it. Like with the TVs, they can break down the TVs, remove the parts that need to be removed, and then recycle the rest. All right, so on average, an American produces about 4.5 pounds of garbage a day. Oh my, that is a lot of garbage. So how could you estimate the amount of garbage you throw away each year? Well, if you know there's 4.4 pounds of garbage a day times 365, that's your number. Little scary. All right, so that's it for today. Thanks.